Okay, so I stopped the video for deformations of line bundles, so I could say a little thing about the classification of line bundles. So I am just going to continue with the deformations of line bundles and prove the theorem that I started in the first part, part 2. Okay, so this is the baby-most case of there's lots of different things. So it's important. Okay, so as in the previous video, we had this x prime, which was a deformation of x over a to a prime, and then we had a line bundle on x. Okay, and in the classification of line bundles, we associate this to some cohomology class Mij in H1 of x O star. So there's a certain cohomology class which we called the class on x of L, which was associated to this. All right. So that's nice. So the basic strategy of the theorem, so this determines the line bundle optomorphism. The strategy that we have is that deformations of L to x prime are going to correspond to deformations of the cocycle. That's the basic idea. So that's that. There's another tool. There's another tool that we're going to use. The tool is as follows. So we have again that I goes into like this a 0. Okay, and so we also have that we can extend this to the deformation here, like so. Okay, so this is the ideal sheaf that defines x, and now there's an important exact sequence. So this has j squared is going to be equal to 0, and there's an important sequence. The important sequence is the following: 1 plus j. So we have this thing that sits inside the units of O of x prime. Okay, so there's this important sequence here. Sequence of abelian groups, and it could be a sheaf of groups. So suppose you view x as a locally ringed space, then the underlying topological space of x and x prime are the same, since this is a square zero extension. And so what do I want to say? I want to say that okay, I want to say, this is what I want to say. If I have two guys here, F and F1 and F2, and they map to the same thing here. They map to F, right? So they both map to the same guy here. Then the thing that we can do is we can take F1, F2 inverse, and it's going to look like 1 plus G, and this is going to be 1 plus J. Okay, and so in particular, G squared is going to be equal to 0. And we're going to use this all the time. Okay, this is going to be used very frequently. All right, so now I can go to the idea, the proof. So the 2 cocycle construction for this class, which lives in H2 of x 1 plus j. So okay, so what we're going to do is I'm going to take, so let of L, let's be Mij here. Okay, so there's going to be some associated cocycle here. Okay, so let Mij tilde. So again, I'm going to say lifts and deformations are going to be the same thing. Be deformations, a deformation or lift / lift of Mij for each I and j. So now j and I cross I. So again, we've in this presentation here, I've really fixed a cover of X. Okay, and now I claim that Mij tilde, Mjk tilde, Mki tilde is okay. It's a cocycle. Check cocycle for 1 plus j. All right, so that's what I have. Okay. So another remark that I want to say is that this Mij that we're building here, it doesn't matter which lift we take. I'm not specifying any conditions in this statement here. All I'm just saying is that I'm just going to pick some guy that's in that's a unit in. So this guy is going to be an O of x prime, and its reduction is going to be this guy, and that's all I'm saying. I guess another thing, this is in Uij. Okay, so that's all this is saying. Okay, so let's prove this. Okay, so let's define. First of all, let's define alpha ijk to be this thing: Mij tilde, Mjk tilde, Mki tilde. Okay, so we know that. So this is congruent to 1 plus. So I guess we should say that this is an element of 1 plus j because, okay, notice that when I reduce mod j, this cocycle here, the Mij's satisfy the cocycle condition. Okay, so the transition maps are compatible, and that's what gives rise to this. Sorry about that, the video cut out. All right, let's continue. So I was talking about the two, I was going to give the two cocycle construction for this obstruction class to lifting the line bundle L to x prime. So the line bundle's on x, and I was talking about the obstruction to lift it to x prime. So let this construction, the classifying element for the line bundle in H1 of X and O star be represented by Mij. So this multiplicative cocycle, let's say, let's put a U here. So where we're fixing a cover of X, so not Xi, just X here. Okay, and so what we're going to do to construct this class, I'm going to construct a cocycle that represents this class, and then I'm going to go forward proving the properties. So for each I and j, we're going to let Mij tilde in Ox prime of Uij. Here again, Uij is Ui intersect Uj. Be a deformation or lift of Mij. So this means that these guys are going to be in x prime, and the reduction mod j is going to be Mij. So and we're going to impose no other conditions. So we're just going to take some random lifts of Mij. Okay, the claim is that this cocycle is that I'm going to define alpha ijk defined to be equal to, well, I'm just going to do a combination like this, jk mki tilde is a check cocycle with respect to the cover for this group 1 plus j. Sorry, 2 cocycle. Okay, so this is what we have. first of all, I want you guys to observe that here, the reduction mod J of this, so this is clearly, it's clearly in here, right? But when you reduce mod J, then the Mij satisfy the cocycle condition, so this is going to be 1, right? And like I said before, so these things are all going to so they're going to be in the kernel of the map, this map from here to here, okay? And the kernel of this map is this, okay? And that's how we get this in here. Okay, so let me just prove that this is a cocycle. And to prove it, it's a computation, and I'm just going to write it out. So what we need to do is we need to compute d alpha of I, j, k, and l. All right? So this thing, by definition, is alpha j k l, alpha I k l inverse, alpha, and now I skip the next one, I j l, and then alpha I j k inverse. So you do this like alternating product of these things. And now I'm just going to write out the definition of this. So it's kind of a little bit of a pain, but I'm just going to do it. So mjk, then we have kl, and then we have lj. And then we are going to do ik, kl, li. And then we have ij, jl, li. And then we have ij, jk, and then ki. And here's, okay, so now everyone gets an m, you get an m, you get an m, you get an m, m, here, m, and then we have tildes everywhere because we were lifting these guys. Tildes everywhere. Okay, and then we need to make sure that we're doing the inverses correctly. So this is inverse, and this one's inverse. Okay, and now all we do is we just check that everything's satisfied, so that this satisfies cocycle condition. So we check that things cancel appropriately. So, for example, here the ij term, this is m tilde ij. This is going to cancel with this one here. Okay, so now we're just going to do this for each one. So here's jk. So now we need to find a jk inverse. So the jk inverse is here. Okay, now we move to the next one, KL. The KL inverse is where? Here. So this one and this one match. Okay, the LJ, so we need a JL. So LJ is here, and then JL is here. So JL is LJ inverse. Now we need IK. So IK and IK here. So this one's a little bit tricky. So IK inverse is KI. Ki inverse is Ik, so these two cancel here. So here and here. Now KL. KL is, oh, we already did KL with the squiggly underline, huh? Okay, Li. Li is, these two go together. So now we've shown, we'll maybe do here. Okay, so now we've shown that this is 1. So it definitely does satisfy the cocycle condition. The next claim that we need to show is we need to show that that it's independent of the choice of lifting. So here we made a decision about some lifts, and we need to show that this is independent of the lift. Okay, so let Mij tilde be one collection of lifts, be one connection, one set of lifts, lift. And Mij tilde prime another, and then let alpha ijk be the cocycle associated to Mij tilde, so ij, mjk, mki, tilde, 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 and then let alpha ijk prime be this one here, and so the one associated to the tildes here. Sorry, the primed tildes. Okay, so that's kind of getting busy notation here. Then the statement is that alpha ijk is equal to alpha ijk here prime is an element of H2 with respect to U in this 1 plus J. Okay, so this is what I need to prove. I need to prove that these two guys are the same. All right, so let's do this. Okay, well, first of all, we have our two guys. We have Mij, so here's the proof. Okay, so we have our Mij, and we have our Mij tilde. Or sorry, we have Mij tilde and Mij tilde prime. They're both lifts of Mij, and now I'm going to apply that trick that I said that they... So we have this thing. We have O of... so X prime here, and this has a map here, and this goes to 1, and then we have this 1 plus J, which is... So we have this exact sequence here of groups, and here we have two guys that are lifted that map to the same thing. So we know that Mij tilde prime inverse, so this is equal to 1 plus, and then we need to choose a letter, Aij, for Aij, an element of J of Uij. Okay, so these two things agree, so they look like this. Now, what we are going to do is we're going to show that the alphas and the alpha primes are cohomologous. Okay, so so what we'll do is we'll take alpha ijk. This is that cocycle associated to this one, and then we're going to take alpha ijk prime, and we're gonna look at the difference of those two things. And when we do the difference of these two, this is elementary again. So jk mki tilde tilde tilde, and then here we have the same thing. Now we just do the tildes primes in an inverse, tilde prime prime prime, inverse, and now we're going to use the commutativity of these groups to clump things together appropriately. So we have the ij parts, and then ij tilde prime inverse, and then we have jk tilde mjk tilde prime inverse, mki tilde prime inverse here. So now we're going to apply this definition, or not? Yeah, I guess the definition of the aij's, or the fact that they both have the same reduction modulo the ideal j. So we get this. And then we have 1 plus ajk, and then we have 1 plus aki. Okay, and now using the fact that j squared is equal to 0, this thing becomes aij plus ajk plus aki. So this uses the fact from here to here that j squared is equal to 0. And this is clearly to be seen. This is the co-boundary of, this is D of 1 plus this collection of ij's. So we have this cochain, so we have this cochain in C1 of U 1 plus J, defined by 1 plus Aij, and then this is the check co-boundary map, and we showed that these two things are cohomologous. So this proves that alpha ijk is equal to alpha ijk prime in cohomology in H2U of 1 plus J, as advertised. All right, so now we're going to continue. So now we need to go with the next part of the proof. So we need to show that, so we're going to prove the first part of the theorem, okay? So the first part of the theorem says that that vanishing of this cocycle implies liftability. So vanish. Okay, so it remains to explain the Torsor structure. The Torsor structure of deformations, of isomorphism classes on isomorphisms classes, classes of deformations. line bundles. Okay, so so here's what we're gonna do. So suppose L is given by the class of L is equal to Mij. Suppose that the class of x prime of, now we're going to take two deformations, Mij tilde, and then the class on x prime of, let's say the second one is Mij tilde prime. Okay, so we've made three choices here. So we made this choice, and then we're making these two choices which depend on this choice. Okay, so now I'm going to define the class, the division of these things. Prime of L prime prime is going to be defined to be equal to, so Mij tilde prime inverse, and this thing is going to be in H1 x 1 plus j. All right, so now we have our definition of this. Okay, and so now we need to show this is well defined. And then we need to show that this division map is so that it's faithful and surjective. I'm not going to show this part. I'm going to show this part. Okay, so so here, so we had this choice of Mij, and we could have well chosen another thing, right? We could have modified this by a coboundary. Okay, and so here we had choices of lifts. We had this choice and this choice. Okay, so this choice depended on this, so these things are reduced to this modulo j. And so what we can do is we can take another choice of these guys. And so what we can do is we can modify this one by a coboundary, and we can modify this one here by another coboundary. So prime tilde prime inverse. So we can modify this one by a coboundary and this one by a coboundary. And here we're going to have that where both bi tilde and bi tilde prime. So these things are in here of u of 1 plus, not 1 plus j, o prime times. So units in the lift or deformation of x, the multiplicative, okay. So then, so where both these guys reduce to bi, a fixed bi. Okay, so then I claim that this class here is going to be equal to the class that we get from here in here. Okay, so so let's just write this out. So so here let's write out the definition. So okay, so we have this guy, Mij tilde bj tilde inverse here. And then now I'm going to do the other one. Bi tilde prime Mij tilde prime bj tilde prime inverse inverse. Okay. So here what we're going to have is, well, we're going to separate this out. So now we're going to use the commutativity of Ox times strongly here. And we're going to say that this is bi tilde prime inverse, and here Mij tilde prime here inverse, and then we have bj inverse bj tilde, and then we have here we have bj prime tilde inverse, and now we see that so now we have our old guys. here. So this is the original one, this co-cycle in 1 plus j. Again, these things both reduce to the same thing, mod j, right? And we use this sequence again, 1 plus j, O of x times prime, and then we have this here. So we use this exponential sequence again, and here, this thing here, they both reduce to the same thing here. So this thing is going to have the form 1 plus beta I. Here, these two things both reduce to the same thing, mod j. So it's going to be 1 plus beta j, or 1 minus beta j, because it's 1 plus beta j inverse. And then here's what we had before. So this is mij tilde prime. So this implies that this construction is well defined. Construction is well defined. Okay, so one last remark is that you could just do this another way too, is instead of taking two guys here and then, or sorry, two guys here and then dividing them, you could take one of these guys here and then modify an existing one. So we know that this guy looks like 1 plus something here. Well, we could take that something and modify it here. And that's how you can view this as acting on the collection of these. Okay, so I'm going to wrap this video up. Thanks for watching. This part, I guess I leave it as an exercise to show that like I said, that this is a torser structure. So that this part here, so that the action is does as advertised, and that shows that essentially shows the torso structure. All right, so thanks for watching. Bye.